in this video we're going to be talking about the data cycle and scatterplot stuff. Some of this you may know already, some of it may be new to you, so make sure you're taking down any notes for any new vocab. So let's first start with the data cycle. Some important things to note is that usually in a cycle you start someplace, you go to the next, and then you continue through this cycle and then it repeats. But in the data cycle, you don't have to necessarily start at one specific place. I could start at formulate questions and then continue, or I could start with the collecting and acquiring data and then continue, and then so on and so forth. So let's actually talk about what the data cycle is. So I'm just going to read down the definitions. So we're going to talk a lot about univariate data and bivariate data. So when we talk about univariate data, it's like a single thing. Think about the stations you did, your age, your height. Those were single characteristics that you found. If I just looked at test scores, if I just looked at time spent on a phone, if I just looked at GPAs across whatever. I'm sorry, if I just looked at GPAs in general. If I add in other things, that's bivariate. So univariate is just one single characteristic of data. Bivariate is then when we're comparing two sets of data, or there are two different variables. So like if I'm comparing age and height, or hours studied and the grade earned, or other variations like that, GPA and age. I'm just using some of the examples up here already. Time spent on phone and test scores. If I'm comparing two different variables, that's bivariate data. And then we saw on the previous page, so I'll just go back really quick, that there are four steps in the data cycle. Formulate questions, collect and acquire data, organize and represent that data, and then analyze the data and communicate results. So we're going to have a chance to go through this cycle multiple times throughout the year. But let's talk about what each step really means. So when we formulate questions, we want these questions to be something we can do with data that we're either going to find or that we can put together. So these questions should explore some sort of relationship between the two characteristics or the variables. And then we're going to look for trends in this relationship, and we'll talk more about what trends are here in a moment. And then step 2, when we collect or acquire the data, this can be collected in different ways, from surveys that are already done, taking surveys in the population, research that's already done, or you doing your own research. Sorry, going on to the next page. Observing, that's kind of part of the research. Doing experiments, doing polls, again, in the community. Doing questionnaire, which is very similar. Acquiring it from a trusted source. I couldn't name one off the top of my head, but probably not like Wikipedia, because it's not always trusted, and it changes all the time. Step 3, organize and represent the data. So we want to show all of the data that we either collected or acquired in points. And when we do this, it's usually going to be on a scatter plot. So previously you may have used bar graphs or histograms or line graphs or any of those other things, but we want to focus more on scatter plots. And then we look for patterns in the data. And we'll talk more about some of those patterns here in a bit. And then we won't really talk about this piece right now, but later we'll come back to this. A line or a curve of best fit can be drawn to show a trend in the data. So when we talk about like trends here, and then we relate it again when we bring it up again, this will all be connected. And then based on that line, that curve, that trend, we're going to make predictions based on the data and those trends. And then step 4, we're going to analyze the data and communicate the results. Look at the data. Does the data answer your original question? Is there some sort of relationship or correlation in the data between the variables. The relationships can be positive, negative, or there can be no relationship at all. So we kind of talked about this in class, like your age and how many pets you have don't really have anything to do with each other. So that would be a no relationship type of situation. You can look at the relationship also in a different aspect. Is it linear? Does it make a line-looking shape? Is it nonlinear? Does it not make a line? Or quadratic, which we'll talk more about, but it's going to be a U-shaped. And then after we figure out all of these different things, we're going to communicate this relationship if it exists or if it doesn't, and then make different final predictions based on this data. So just to go back and summarize again, you can start anywhere in this data cycle. Usually you start with formulate questions, but that doesn't have to be first step. But steps in the data cycle are formulate questions, collect and acquire data, organize and represent data, analyze data, and communicate the results. Keep those steps in mind as we move forward. So we're going to look at some scatterplot stuff. So this you should know already. But just in case, we'll review really quickly. So with a scatterplot, you need a title, something that tells you what this scatterplot is representing, kind of putting the two pieces or the two characteristics or variables together in something that could be like a heading. Like if you read it in the newspaper, oh, this is what this is about. And then on your x-axis and your y-axis, they both must have a label. So something that tells you what exactly does this data at the bottom and on the side represent. And then when we talk about the spacing, so the spacing on an axis must be in equal increments. So I can't start at 0 and start counting by 2s and then all of a sudden start counting by 5s. It doesn't work like that. However, the spacing on each axis, so like the spacing on the x-axis, doesn't have to be the same as the y-axis. It also depends on the data that you're working with. So here, the numbers I'm seeing, I see that this is counting by 4s on the x-axis and counting by 40s on the y-axis, so visually the number's there, but if you actually count the lines in between, it's actually counting by 2s, so you can look at that either way. Alright, so we're going to take a scatterplot, we're going to construct it, so this would be like collecting or acquiring data. We kind of acquired data in this. And then we're going to describe the relationship, going back to organizing and representing the data. So that's what we're doing here in the scatterplot. So on this, make these right here. The hours on the phone is going to be my x-axis, and then the test grade or the test score is going to be my y-axis. And I'm going to put these to the best of my ability on this. So I see visually, my numbers on my x-axis are counting by 2s, which means the numbers in between are 1. And then visually, my y-axis is counting by 20, and the numbers in between would have to be 10. All right. So then hours on a phone would be 5. I'm going to start at my x-axis, go over to 5, and then go up to 50. That would be somewhere right here. Oh, change colors on me. And then 2 and 95. So I know where 90 would be. So if I go over to 2, go up to 90, 90 would be right here. And since this isn't counting by 5s, I would have to say it's somewhere in the middle right here. 3 and 82. So again, I know 80 is right here. 85 would be in the middle. So I'm going to say it's somewhere in between there. 7 and 44. This is going to be really close. It's almost going to look like 45. Excuse me, actually, I'm going to make that a little bit higher. And then 2 and 70. 5 and 50. Oh, there were 2 of those. So it changed colors on its own, but usually you would just have the same point. You wouldn't actually be able to tell that there was 2 dots plotted there. It would just look a little thicker, I guess. 4 and 66. I'm going to make that a little bit higher than half. 1 and 86. Again, a little higher than half. 7 and 90. And then 8 and 25. Alright, so as I'm looking at this, and I want to describe it, I see that as the number of hours on the phone go up, the test scores are going down. So in that case, this would have a negative relationship. I'm going to say what I said first. Oops, I meant up. So that would be a negative relationship. Usually when one thing goes up and the other goes down, that's a negative relationship. I can see it's kind of makes a line. They're not like all together in a straight line, in a straight diagonal line, but it kind of makes a line. So I can say it's a linear relationship. And I can also see that even though for most of the cases, as the hours on the phone go up, most of the cases the test scores go down. That doesn't happen here. So whatever happened there, the hours on the phone didn't change their score. They still did pretty well. That's something we're going to talk about. It's called an outlier. When it doesn't really match the data and it's kind of out there by itself. I don't remember exactly the descriptions I had on here, so I'm just going to show that really quickly. So there's a negative relationship, we said that, with one outlier. So I didn't say the exact points, but we did find that point at 790. As the number of hours on the phone increases, so I did say it went up, the test score decreases, and I said it went down. So other words to use. But that's exactly how we would describe it. Talk about the relationship. Is it negative? Is it positive? Is there no real relationship? This one didn't say that it was linear, which is fine. It talked about that outlier, and it talked about the actual characteristics and variables and how they related to each other. We're going to do just a few more. So same thing, we're going to create a scatter plot, describe the association. So we're going to organize and represent, and then communicate the results again, just as we described it in the last one. Oh, I didn't say this, but visually this is counting by 20, so there's 10s in between on the x-axis. Visually the y-axis is counting by 2, so there's 1s in between. So go ahead and graph that to the best of your ability. So 55, if this is 50, 55 would be like right here. So it would be like in the middle in here. Same thing for 25, and 7.5 would be like literally in the middle. Okay. So again, we have, well, first let's go in order, sorry. The association between the two. So as the age and years increase, if we're using the words from the previous one, the number of miles walked decreases. So I can say that this is a negative association. Right? And then using that data, so we're back in the data cycle, just going back to it, referring back to it. Since we kind of just analyzed it, analyzed the data, we communicated the results. Now I can formulate questions, which is what part B is doing, to refer back to the data to answer. So based on the scatter plot, predict the number of miles a 13-year-old would walk. So 13 would be somewhere like right here. So it looks like 13 would be like maybe at 10. If I'm following the line that's created here, but an 85-year-old, somewhere right here, they may walk less than 1, maybe 0.5. And those are just predictions. Right. So this is the actual answer response. We did get these answers, but I just wanted to show you that the 13-year-old would walk approximately. So we said 10, but we don't know for certain. So that approximately is like about. They should walk about 10 miles. The same thing for the 85-year-old man. They should walk about 0.5 miles based on our data. All right. So now we're going to describe some scatter plots. So we've been given the data already, and we just want to describe like whatever we see. So first we're going to try and use, we're going to talk about whatever we see first, and then we're going to use some more vocab, like these words at the top: gaps, clusters, outliers, and then some other vocab. Sorry. So we're not going to do all of these, but some of them. So if I'm looking at number 1, we kind of talked about how the some of the examples we did were going down, like as the x's increased or went up, the y's decreased or went down. So that was a negative relationship. And I see that this would kind of be the same thing. It would have a negative relationship. But when we talk about the relationship, we're really talking about their correlation. How does the x-axis or that x variable correlate to the y-axis or that variable? And because their relationship is a negative, that makes it a negative correlation. Okay. And a lot of positive and negative correlations are linear. Remember we talked about it makes that line. So I could have said I wanted to add linear in between. Do it like this. So a negative linear correlation, and that would kind of describe everything there. So in this one, if I'm looking at gaps, clusters, outliers, none of this is really clustered together. It looks like there's gaps, but it's like evenly spaced, so not really. and then there's no real outlier. So that's just a negative linear correlation. If I look at number 2, it's definitely facing the opposite way. So I see as my x values keep going up, my y values are also going up. So like whatever this is, it goes up. Whatever this is, it goes up. And so on and so forth. So that would be the opposite. That would be a positive linear correlation. The board is not letting me write. There we go. Try again. There we go. Sorry. Pretend all of that is in one line. The board just was having issues. But positive linear correlation. And then using our words up here, it kind of looks like there's a gap right here. But I think they want it to be further apart for that really to be a gap. But I can definitely tell there's a cluster. Draw. There we go. I'm going to get rid of this gap, but definitely say that there's a cluster because there's a bunch all together. And then let's do 3, 4, and then 5. And then we won't do 6. And you could try 6 on your own. So 3 is not really making that line shape. So because of that, I can't even use words like negative, positive, or anything like that. I'm going to say that this is nonlinear. And later in the year, we will talk about what specific type of function, I'm throwing out words that you may or may not know, what shape that actually is. There we go. Okay. And then for number 4, as I'm looking at that, it doesn't really seem to be going up or down, like increasing, decreasing, together, or apart. So I would say it doesn't really have a relationship. That would be a no correlation. And I can say that it doesn't have a linear relationship or no correlation. And then in number 5, so this, it definitely looks like it's making a line, but it's not really going up or down. So I can't say it doesn't have a correlation, because it's definitely making something, but maybe not positive or negative. But I can also see that there is definitely a gap here. We didn't use the word outlier, but if we had seen, like, for number 1, some point way out here, that would have definitely been an outlier. Or for number 2, something way up here, that would have been some outlier. Number 3, like something not with everything else, that would have been an outlier. Number 4 can't really have an outlier because it's all over the place. 5, an outlier might be like further up or further down, away from the rest. But if we had to specify it, I guess we'd say no correlation. Even though it definitely looks like a line, so that one's kind of misleading. So we talked about positive, negative, no correlation, and then some of the other ones, but then I want to talk about one more. So if you're looking at the data, and the data is really close together, so like, it's kind of hard when there's gaps or clusters, and not so much clusters, but in like number 2, they're kind of really close together. They're almost basically making a line. I could say that that one is more of a strong positive linear correlation. if you're looking in the answer key, I think I left out that word, but it is closer together. They're making more of a line. Some of it is kind of almost on a line. Whereas number 1, because it's kind of so spaced out, I can say this is a little bit weaker. Like it's close to making a line, but not really. Anything that's nonlinear, well, nonlinear has its own category, so I'm not going to talk about that. But if it's no correlation, it can't really be weak or strong. That's not true. It's more so weak. It can't be strong at all because there is no correlation, so you could say that. Yeah, okay. Okay, and then we're just going to do one of these just to get you kind of thinking about the information. So again, just to go back to our data cycle, we are given some data. So that would be in our collect and acquire. We've acquired some data, and we're going to, it's already organized for us, so we don't really have to do that part, but we are going to analyze this data and communicate some results from it, given these questions. So here it asks what information is shown about the X and the Y values. So the X values are the number of hours on the phone. And then the Y values would be the test scores. Right. And then using that, how many students were surveyed? So it looks like we would just count each of the dots. So I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there were about 16 students, there were 16 students surveyed. And then if we were to describe this relationship, well, the more hours spent on the phone, the lower the test score is. So this is a negative relationship. This is a negative relationship. I can say the data is pretty strong because all the there's enough data and they're pretty close together. So the number of hours increase as the number of hours on the phone increase. I should probably say that specifically, sorry. The test scores decrease, and that would be a negative correlation. And then it asks us to identify the outlier. So in theory, in actuality, we really talked about this problem already, and we kind of already touched on all of these pieces. We just didn't have all these questions really with it. So we know this is that outlier because it's not with the rest of the data. So if I were to identify like what exactly, that's going to be at 9. So looking at the x-axis, starting at 9, going up to 90. So they spent about 9 hours on their phone and still got a 90 on the test score. Right. And then if we were to explain how it could have ended up on the scatter plot, maybe they
studied so much, maybe on their phone, that they were able to do well on the test. Or, and definitely not suggesting this, they used their phone while on the test. Who knows? Could be either of those. I'm not going to rank all of that, but it could have been either of those. So hopefully you have some more ideas as to how scatterplots work. And now we're going to, if you haven't already, get into some more scatterplots activities. And make sure you do your delta math.